Hi guys, welcome back to Python versus YouTube channel where curiosity meets the call. Today we'll be discussing about how to create a real-time traffic data visualization application using Python. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions so I can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code on Google Trafficking. So as usual, you can see we have imported a couple of libraries that are necessary for the program. Includes sys, which provides access to some variables used or maintained by Python interpreter, and for import request, which allows to send HTTP requests easily. And then we have import pyqtgraph as PG. This paragraph is pyqtgraph is Python library for creative, interactive, and scientific plot using pyqt. And from the PyQt, we have Qt widget and the Q application, Q main window, QV box layout, and QV widget. So these are used for plotting of the graphs using the GUI application. And then we have Qt core, Qt timer, which provides the timers that can be used to trigger the events at a regular intervals. Let's move on to the next. So as you can see, there is one main class which is traffic group under which we have init function, which is the basic UI interface, and then we have definition of update the plot. And the second class is the main window class under which again there is a GUI interface function, and then we have to start the main event. So let's see what happens in the first class and first function. So under the class traffic graph, we have def int. So here what happens is first of all, definition of a class named TrafficGraph, which inherits from the QWidget class. This class represents a widget that displays the traffic data. And coming to the definition in itself, defines a constructor method for the traffic class. And then we have super.int, which calls the constructor of the parent class, which is the QWidget, to initiate the widget. And then for setting up the layout, we have self.layout QV box layout self. This creates a vertical layout and assigns it to the layout attribute of the widget. And also we have self.graph widget is equal to pg.plot widget, which creates a plot widget from the pyqtgraph library and assigns it to the graph widget attribute of the widget. And then we have self.layout.add widget, which adds the graph widget to the layout. And then we are setting up the plot. So for setting up the plot, we have self.plot data, which initializes an empty list to store the plot data. And we have self.curve is equal to self graph widget plot pen B. This creates a curve, which is a line plot on the spot on the plot widget with a blue pen color B. B is the denotation of the blue color and assigns it to the curve attribute. Then we have to set up the timer to update the plot. So we have self.timer q timer to create a q timer object and assign it to the timer attribute of the widget. And we have self.timer timeout.connect self.update plot. This connects the timeout signal of the timer to update plot method so that the method is calling when the timer runs out. And finally, we have self.timer start 1000. This starts the timer with a timeout interval of 1000 milliseconds, which is equal to 1 second. Moving on to the next, we have update plot function. So here, update plot function, firstly, what happens is it first defines an update plot function, and then the next sentence is to fetch the traffic data from Google. So we have given the URL as www.google.com, and here the URL of the website from which the traffic data will be fetched is there. And we have a try and except loop executed in which response is equal to request.get URL. Here it sends an HTTP request to the specified URL and assign the response to the response variable. And we have soup is equal to BeautifulSoup response.text HTML dot parser. Here parser the HTML content of the response using the BeautifulSoup and assign the parsed data to the soup variable. Traffic data is equal to length of response.text. Here we are computing the length of the response text and assigning to traffic data variable. And in except request exception as E, here it catches any exceptions that occurs during the request. And we are printing out if there is any exceptions, we are printing out an error statement, which is error fetching the data. And for return, we have the function of return, and then we have to add the data to the plot. How do you add the data to the plot? We have self.plot data, append traffic data. Here the fetch data to be plotted data is listed, and self.curve set data. Here update the plot curve with the new data. Moving on to the new class, second class of the program. Firstly, here new class of main window is defined. And later we have a function called def init self. Here a construction method for the main window class is defined, and we have super.int, which is called the constructant of the parent class, which is the q main window to initialize the main window. And we then later we have to set up the main window. So we have self.set window title Google traffic graph. So here for the graph, we are giving a title of Google Traffic Graph, and we have self dot set geometry 100, 100, 800, 600. Now, what are these numbers? Basically, the first two are x and y axis. So we are starting the graph plotting from x is 100, y is 100, and then we have the width and height of the graph. And then let's come to the setup of the traffic graph widget. Here we have self.trafficGraph is equal to traffic graph. Here it creates an instance of the traffic graph widget and assigns it to the traffic graph attribute. And we have self.setCenter widget, which is self.trafficGraph, the central widget of the main window to be the traffic widget window. Moving on to the next part. Here we have a code to start the program. So let me just explain what each sentence does. First of all, if name is equal to main, if check the script is being run as a main program. And for starting off PyQt application, we have app is equal to queue application sys.r, which creates an instance of the queue application class, which represents the GUI application. And we have main window is equal to main window. Here an instance of the main window class, which is also run. So let's move on and see what is the output of the program. So as usual, I'll go to where the file is stored, copy the name of the .py file, go to command prompt, python space file name .py. So as you can see, the window is appeared. We have given x and y axis as 100, height and width as 800 and 600. So can you see where the traffic is picking up with the time? So every 1,000 millisecond, which is equal to 1 second, the graph keeps updating from the data extracted from www.google.com. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.